Now this is going to be all about graphing a polynomial function without a calculator. So all the things that we've been learning in behavior, zeros, their multiplicity, and turning points, we're going to combine those now and look at how to graph one of these things. So we first need to set up the rules here, or the sequence. Graphing a polyfunction. 1, find end behavior. 2, find zeros and multiplicity. So find the x-intercepts and determine what they're doing at the x-intercept. Step 3 is find y-intercept. 4, TPs, turning points. 5 is plot and graph. Plot/graph. All right, now let's get going. So example 1, graph, let's call it f of x equals x cubed minus 3x squared. Using the steps over here. All right, so step 1, we need to determine end behavior. How do we determine end behavior? And again, and pause the video and try to work through all these yourself. That would be great. And then come back and try to follow me, or just pause it incrementally as you get stuck. Oh, and unpause it if you need help. So to find end behavior, we need to look at 2 things. We need to look at the degree and the leading coefficient. So we start by looking at the degree. So n here is equal to the highest exponent, which is 3. Now is 3 even or odd? 3 is odd. Odd, opposite. O. Ends do opposite. Ends do opposite. Then we need to look at the LC. So we know they do opposite, like this. We just need to determine if it's, we need to determine if it's an increasing or decreasing looking. So the LC is the leading coefficient. It's the coefficient that's attached to the degree. So that's a 1. So LC is 1, which is positive. Positive. So that means it looks like ends are doing opposite, and it's a positive looking function. It's an increasing looking function. So this is how an increasing function would look. And let me move my hand. It goes down on the left and up on the right. So I know it's going to look like down and up. And that will be helpful when we get to the final step and we put everything together. Those will be helpful to us. All right. Step 2 is find the zeros and give their multiplicity. Let's do that now. 2. So we have x cubed is equal to 3x squared is equal to 0. Remember, finding zeros, you set it equal to 0. And pause the video and try to do it yourself. If you need help, then unpause it. So I noticed that both of the terms have an x squared in common, so I can take that x squared out, and I'm left with x minus 3, and that's equal to 0. Now I can break these two up and set them separately equal to 0. X squared is equal to 0 and x minus 3 is 0. Square root both sides, so I just get x is equal to 0. Add 3 over here, so x is equal to 3. So those are my two, I need to write them as points. 0, 0, 3, 0. Alright, now pause the video and try to determine the multiplicity yourself. So to find the multiplicity, we need to see where these points originated from. So we go back to right before we broke them out, and we see where 0, 0 originated from, and it came from this x squared. So that is a 2, which is even. So that means it's even multiplicity. Even multiplicity, multi. That means it's tangent to x-axis at 0, 0. I'm not sure if you can see that, but it says even multiplicity tangent to x-axis at 0, 0. I was trying to save the board over there when I find the y. And then this 3, 0 originated from here. Its exponent is 1, so it's odd, so it's odd multiplicity. Odd multiplicity. Odd multiplicity means it crosses the x-axis at that point. Crosses x-axis at 3, 0. So those are also very important things to remember. We need to, when we get to graphing, we're going to need to know this in combination with this, and things will start falling into place. I'm just running out of room here, so we'll just find the y-intercept over here and the turning points. 3, find the y-intercept. So to find the y, we let x equal 0, and this is our function. So now just replace all the x's with zeros. Which is equal to 0. So that tells me my y-intercept is 0, 0. And then number 4, the TPs, the turning points, is equal to n minus 1. We know that the degree here is the highest exponent, which is 3. And we found that in part 1 also. So this is 3 minus 1, which is 2. So we're going to need all this info to be able to graph this. So what I'm going to do is I'm going to graph it over here, and I'm going to move, I'm just going to rewrite the y in, this is just for me. You don't have to do this because you have it all there nice and neat. 0, 0, and TP is 2. Here is the x-axis. Be sure to label so I know what's going on. Alright, so what we want to do first, let's just start with the first step and see if it's helpful to us. And if not, then we will move on to the next and remember to come back. So step 1 told us end behavior. So I know that it's going to be going down on the left and up on the right. And so we don't know exactly but what we can do is we can just go ahead and draw them on there like that. And then when we start getting into the details and finer, we'll move these around. So they'll either come in closer this way, they could shift. But just as long as we have the general idea. All right, step 2, the x-intercepts. So we can go ahead and plot those. So we have 0, 0. So we'll put a big blue dot here. And then 3 comma 0. 1, 2, 3. So there's our two x-intercepts. And we know that 0, 0 has even multiplicity. That means it's tangent to. That's not super helpful right now because we don't know if it goes like this or if it's up here it goes like this. So you can kind of start figuring that part out now, but just in case, let's just leave that off. And then 3, 0, it crosses the x-axis. So it's either going to cross like this or it's going to cross like this. And you can probably kind of figure out that it's going to cross like this because you know that you have to end this way. You know you have to end with the far right going up. That's why the end behavior helps you. It lets you know where you're crossing or which direction you're crossing, whether you're crossing up or down. So that's helpful info. Now we have a y-intercept of 0, 0. So we have that point already. And now we have the turning points. So we have 2 turning points. So it's going to go increasing to decreasing and decreasing to increasing. It's only going to do that twice. So we have all that we need now. We know that here it crosses the x-axis and it's going up on the far right end. The end behavior is going up. So we know it has to cross like this. So it's going to connect to the arrow there. And so this comes down here and we wind up over here. So, and I know that this 0, 0, it is even multiplicity, so it has to touch and turn around. So we have to connect this over here somehow. So that's where it comes into play. This touches and turns around just like that. And then these two have to meet somewhere right there. So, and I'm not concerned at what value this is right now, that's not a big deal. As long as you get the points, you can connect them correctly, and you can find the flow here.